Okay, so the last thing we're going to take a look at today is not actually attacking directly over a network. For these attacks that we have done today, all of these attacks that we've done so far, it really requires that you have network access into the system to realize these vulnerabilities. We're going to try something a little different now. We're going to pretend that we are doing access through a website. So when I start up my browser, if it doesn't go directly to the IP address, again, type in the IP address that we are going to target, the 101 IP address, and you should see something like this: Metasploitable2, again with more ASCII art. And you have a list of sites that you can attack. Each one of these has some vulnerabilities to it, but we're just going to focus on DVWA today. DVWA stands for Damn Vulnerable Web Application. And as you can see again in the handout, if you select web attacks with DVW, or just as web attacks in the handout, you will see that we have this tool here. We're going to log in with admin, and the password is password. Now your first instinct should be, after what we just saw, it's like, oh my god, why did they use password? Anybody could figure that out, especially with a username like admin. Admin is a common admin username. Exactly. That's thinking like an information security professional. But this site was designed to be vulnerable. Okay? This application has degrees of vulnerability. All right? Currently, the settings for the security is set to high. Okay? But we can change that so we can attack it. And I use this site all the time with my students, not because it's just good for doing pen testing, but it shows you an example of bad code when you're developing a website versus very good code that's very good at mitigating attacks on your website. And you can take a look at the differences and realize these are examples of good code. These are the kinds of design considerations I should keep in mind when I'm developing my websites. I use this site all the time in my classes to help my students recognize bad coding and fix it with good coding in their source code when they're developing applications. But we're going to take a look at really, really bad code. So along the side here, along the left side, we have a series of navigations. One of them is DVWA security, and as you can see, it's set to high. We're going to set it to low and submit, so that it says security level is set to low, and more importantly, the information in the lower left corner says security level low. Okay? Once that's done, we can start doing some command execution. Okay? Now, this is something you rarely see, and if you're ever out doing pen testing activities that we call capture the flag, if you ever see something on a website that says ping, first thing you want to think of is, command chaining, command execution. I'm going to try and do more than they want us to do. So the ping command is actually used to see if a site is there and if it's responding. You can use a machine name or you can use an IP address. We're going to use an IP address. Actually, we're going to use a name called localhost. So it's kind of a machine name, or, it's a special name, but it refers back to itself. So I'm going to say, hey, ping me. Ping localhost, just like that. And after a second, I just hit enter on the keyboard, and after a second, it pings itself, and it works. So that's perfect. So because my security is set to low, I'm going to try and do what we call command chaining. In the Unix world, when you're typing a command, you can actually type multiple commands on one line, separating them with a semicolon. It's called command chaining, and again, it's something sysadmins do. It's also something that hackers use to exploit systems, just like the nmap command is a good systems tool that hackers use. Command chaining is a good sysadmin technique that hackers take advantage of when they're trying to compromise websites. And it involves doing two commands. Now we're going to assume, for argument's sake here, that when the command is being run, this is what's happening behind the scenes. When I type in a machine name right here, this is what happens. Ping, and then whatever that machine name is. So when I type in localhost, that's what happens. In the background, it pings localhost. And what I want to do is I want to finish the first command and start another command. And the easiest command is ls. I can also do ping localhost, who am I? I can do very simple commands, but the ping is already there. So all I need to do is supply this other stuff. Localhost semicolon to end that first command, and then ls to start the second command at that point. So let's try that. So I'm going to say localhost semicolon, who am I? And after it finishes pinging itself, it runs the who am I command. And it says you are www data or www data, okay? Which makes sense because that's a typical user when you have Apache running on a system. And we know we have Apache running on a system because when we did our service scan, it told us that our HTTP server was Apache. So the fact that we see www data here makes sense. Perfect. Let's try another one. Localhost semicolon ls. And then it'll go through and it'll start doing a directory listing. And you can use this to navigate through the whole file system. This is a huge vulnerability. So much so that modern versions of PHP, which is what this site is based on, no longer allow this by default. They turn it off by default, and you have to turn it on purpose. Because the next thing we're going to do, remember how we took a look at the password file earlier? I'm going to ping localhost again, and I'm going to cat etc passwd. I'm going to see if I can look at that list of users on my system. And it looks like I have a typo. Localhost semicolon cat etc, I have too many s's, passwd. Again, I did it. I have 3 s's. I don't know why I have so many s's. My name is Steven. I must really like the character S. There we go. Much better. And that, I'd like to say I did this on purpose, but it goes to show that typos, when it comes to this kind of stuff, typos will get you every time. So when something doesn't work as expected, try again. There's a chance you may have mistyped. The worst thing a system auditor can do, an information security auditor can do, is try and test an exploit, mess up with a typo, not find the exploit because they messed up with their typo, and then go back and say, yeah, everything's fine, don't have to worry about it. Meanwhile, they've left a real-world vulnerability in the system for somebody who doesn't have a typo to realize. So check your work. That's what I did here. And we got a list of users. And again, at the bottom of our list of users, we have Cartman, Kenny, Kyle, and Stan. And we've already seen this. We can use that list of users. We can include that with our Metasploitable command that we did, or sorry, our Medusa command that we did all the way up here. We can do the Medusa command with our users that we just discovered, and we can try compromising the system. Now, your obvious question at this point would be, hey, can I see the shadow file? Well, remember, you need to be root to see the shadow file. And the last time we looked, we weren't root. We were www data. But we'll try. You never know, right? So I'm going to ping localhost again, and I'm going to cat etc shadow. And I don't get anything. And I can check my spelling and make sure, but this time I know it kind of makes sense. When I go through the browser, through Apache, I'm not root. When I go through those vulnerabilities, they're so bad that I am root. But in this case, I'm just a regular user. I'm a regular system user in this case. Okay? One last thing I want to take a look at is compromising this system using SQL. Okay? It's the last thing we're going to look at, and it gets a little crazy here. Okay? We took a look at the shadow file, and it didn't work. We took a look at the password file, and that did work. So we can see different files in the system. So, and we also did the ls command, and I'm not going to go into the process of using ls and cd to navigate through the system and trying to find different directories and files in the file system. Let's assume, for argument's sake, that we were going through and we found, and by the way, this is something that hackers like to do all the time. They'll get a text editor. Actually, you know what? I'm not even going to do that. I'm going to do that over here. All right. I'm going to use a work file, and I am going to slowly build up my exploit. All right. So I want to ping localhost semicolon, and I want to take a look at the var www. That's usually where websites exist in the file system of a Unix server. All right, specifically Linux, specifically Apache running on Linux is in the var www. Sometimes HTML, but for our purposes, this is going to work. There's going to be a directory also for this web server. It's dvwa. And in that, there's a directory called config. And in that config directory, there is a file called config.inc.php. Now, to go through and find that using command execution is problematic. But that's how you would do it. It's more complicated than we have time for today, but that's how you would do it. But now I've got my injection. After I go through and I find all of these directories, I can build my injection. I highlight it, I copy it, and then I paste it right there. All right. And when I submit, it doesn't look like it worked. However, you don't know that, right? Sometimes things are hidden from you. If you right-click and select View Page Source, I think that's the best way of doing it. Either right-click and View Page Source, or Control key and U. Control U works as well. We can actually go through the results and look what we found here. It did work. It just tried to hide it from us. Okay, so when we take a look at the source code for this page, there's nothing here on this page, but right-click and View Page Source. Hidden in the background is the information we're looking for. That's another thing you want to look for. Sometimes these things are hidden in the background from us. Okay, so I've got database connection information, which is awesome. I can now try and connect with that. So there's a couple of different ways of doing this. I hope you left your connection running earlier, and we're going to take a look at that right now. Okay, but it's not going to work in the shell we have here, so we're going to have to create a slightly better shell. Okay, I'm going to enter so it's a little easier. We're going to use Python to create a more interactive shell that we can then run an interactive program like MySQL. And this is where it gets a little tricky, but again, this is the kind of stuff that hackers do all the time. So we're going to do Python. We're going to execute a command, -c for command. And the command we are going to execute is actually two commands. Import pty, which stands for terminal, and then pty.spawn, open bracket, open double quotes. I've already used the single quote here, so I'm going to open up double quotes here, and the shell we're going to spawn is bin bash, /bin /bash. Closing double quotes, closing bracket, closing single quote. Single quote, single quote. Double quote, double quote. Bracket and bracket. Okay, so this should give me a better shell, and right away it does. It shows me that I am root on the Metasploitable server. Perfect. And now, because I have localhost as a server, the username is root, and the password seems to be empty. So I'm going to try connecting on localhost to MySQL. All right, database variables is MySQL. The other one's commented out. All right, Postgres is commented out. So we're not using Postgres, so we're probably using MySQL. So I'm going to go into MySQL, I'm going to try the user root with no password. So let's see what that looks like. Okay. So it's going to be MySQL -u for user root. And we're in as root. And one of the things you can do is show databases. You're going to need a semicolon in most cases at the end, and it's just generally a good idea to do. So what we have here is we're actually into the database. We could at this point exfiltrate all of the data in those databases. For example, and this is not in the notes, but I'll just show you quickly. I can say use dvwa. These are all SQL commands, right? Show tables. There's a table called users. Select star from users. And now I've got all the users in the system, including their password hashes. I can exfiltrate that data and crack those passwords as well. I hope you enjoyed this. This is the kind of thing that hackers do all the time. I'm sure you noticed that I was jumping around with a number of different technologies, and unfortunately that's one of the things that you need for pen testing. It's kind of the reason why I teach it at Red River College. I'm one of those, as you can see by the beard, I'm one of those old school geeks who's been playing with computers since the 80s. Alright, so you do the math. And I've been hacking most of my adult life, and I was doing it even before I knew that hacking was hacking. But I've been in information security, I've been in information technology most of my adult life, working in databases, working on networks, working in web development, working in Linux. And all of those skills together is what makes me able to do pen testing activities. You need to bring a competency in all of these different skills together to be a pen tester. And if you enroll in the information security program at Red River College, I can give you a lot of those skills. You're going to have to build on them. It took me 20 years before I even knew I was a hacker, but you will get there. And it's a little easier now than when I went through with it. I hope you had fun, and hopefully to see you at one of the hackathons in the future.